And so the state of North Carolina says that, thank you, Gracie, says that we need to know these four centers of triangles. So we're going to do these four centers of triangles. Now, some of these are more useful than others and have some properties that are helpful. Honestly, the last one, the orthocenter, I'm not really sure what it's used for very often because it doesn't have a lot of properties of it that can help you find things about the triangle. But we'll learn about it a little bit anyway. So the first one that we're learning about is the circumcenter. Okay, the circumcenter of, I don't know why that says circumcenter and incenter right there. Incenter's coming up, but this page is just circumcenter. So the circumcenter is where the perpendicular bisectors of the triangle intersect. So this first blank right here is perpendicular bisectors. Okay, so if you think about what a perpendicular bisector is, you do this in Math 2, because I know Miss Martin's kids were doing it the other day whenever she was out. But perpendicular bisectors is a line perpendicular to the side, meaning that you've got right angles, that bisects that side. What's it mean to bisect? Cut in half, right? So it cuts it in half. So this little line right here is perpendicular to side AB, and it cuts side AB in half because those two pieces are equal to each other. So where all of the perpendicular bisectors intersect is called the circumcenter. The circumcenter is always equidistant from the vertices of the triangle, the vertices being your edges here, those corners of your triangle. So if you have colors, they might be helpful here. So our perpendicular bisectors here, I'm going to do those in red. These three lines right here are our perpendicular bisectors. They go from the middle out to the edge, they're perpendicular, and they cut that side in half. So if we list them, it would be D, P, P, E, and F, P. Those are our perpendicular bisectors. The circumcenter for this would be P. And then it asks you to list all congruent segments, but that ends up taking forever for this. Rather than that, it's already marked on your picture for most of them. AD is congruent to BD, BE is congruent to CE, and CF is congruent to AF. So those are all congruent to each other. I'm not going to list them here, and you don't have to either. There is one more set of sides that are congruent to each other, and that comes from the statement we had up here. The circumcenter is always equidistant from the vertices. So it's always the same distance from your vertices. So these three lines right here are always equal to each other. So I'm going to put like 4 tick marks there to show that those are equal to each other. Okay. If you want to kind of do your little note card as we go along, this is the first box that you've got there, the top left corner, I would add to it that is the circumcenter. I would label those perpendicular bisectors, and I would add the little tick marks. In fact, I'm gonna pull it up so I can do that. Let's see where. There it is. So here I would label this the circumcenter. I would label these the perpendicular bisectors. And if I had a highlighter, I would, oh gosh, I would not highlight it that. I would highlight these three here to show and mark that. Yes. Might be a good idea to like highlight those. Perpendicular bisectors there. Okay, we all got everything down? So the little blue lines are your perpendicular bisectors. Those are they are perpendicular to the sides, and they cut the side in half. So the three blue lines that I have there are perpendicular bisectors. The other lines that I have highlighted are equal to each other. Your perpendicular bisectors are not necessarily going to be equal to each other. In fact, most cases will not be. All right. Rather than do the problems that I have there in the notes, we are going to do a problem from the worksheet. So, oh gracious. Let me just open up a blank Word document, and then let me open up Alright, let's go down here. Let's look at number 1. So this is on the worksheet here. Alright, so this one tells us that this is a circumcenter. So what I like to do for these problems is I like to go just draw in everything I know that's easy even before I look at what they're asking me for. So a circumcenter means that you've got perpendicular bisectors. So that means this would be a perpendicular bisector. This would be a perpendicular bisector, and this would be a perpendicular bisector. they're telling us this is a perpendicular bisector, that means the sides are cut in half, right? So I would know EB here, that'd have to be 18 because this side over here is 18. What would the length of AD right here be? 15? Because it has to be half of 30, and this would have to be 15 here. DC will be 15 as well. Do we know CF and FB? The 9 is this little short piece right here. So no, we don't know it easily. Okay, there's a couple more numbers that we can know fairly easily. Not FC. I mean, we can find it, but it's going to take a little bit of work. What about CG or AG? It is 22. So this will be 22, and this one will be 22. Smell it, hand it back in, please. All right. So, some of these that ask us are the ones I've just filled in. I'm just filling in the ones that are like pretty easy to find because they are the same or they're just half. So they asked for AD, that one's going to be 15. They asked for FC. FC is not as easy to find. Any ideas on what we can do for FC? So we'll require you to remember some review stuff back from maybe like probably 8th grade, I think is when you do it. You definitely use it in math too, though. Uh-huh. Nope. No, 180 would be for angles, and we're going to use something like that on one of the other ones, but not on this. No. You could possibly, like there's some things that this could come up within for, like, if you're designing things or building things, possibly. Here, the answer to this is super. It's something you know how to do. Mm-mm. You're thinking angles, and we will use that in a minute, so hold on to it. But that's not it. All right, let me highlight something here. I'm going to highlight. Why is my. There we go. I'm going to highlight this. Imagine that's all you had. It's not 18. It's not. I don't think it has to be 18. It does look like it's 18, but I don't think it has to be. What shape have I highlighted here? What type of triangle? A right triangle. And if I have a right triangle, what can I do? If I know two sides and I need to find the other. It starts with a P. Pythagorean theorem. A squared plus B squared equals C squared. For this, which side is C? Which side is your hypotenuse? Is it 9? Is it 22? Or is it this one right here that I don't know? Is the hypotenuse? Hypotenuse is the longest side. It always has to be across from your right angle. It's going to be 22. So 22 is your C. It doesn't matter whether you do which one's A or B. So I'm going to say x squared plus 9 squared. Okay? So we can pull up Desmos here. All right, and for that, I know 9 squared is just 81. 22 squared is 484. So I've got x squared plus 81 equals 484. What do I do next, Zoe? To solve that for my x. X squared plus 81 equals 484. What would I do to solve that for x?
Would you minus 81?
Yep.
And then divide by x?
Nope.
Square root.
I'm going to have x squared equals 403. And to get rid of a square, square root.
Oh, yeah, that's right.
Square root.
I didn't see that as a square root.
Yes. And we're getting 20.075. So that is for FC, 20.075. So because you end up with right triangles for this, Pythagorean theorem is a skill that you're going to use often to solve these problems. Yes. And so since we got 22 and 18 here, we'll get a different number. So, but EB, that one's an easy one. That one's just 18. AG, we've already labeled. It's 22, right? Those are the easier ones. But as Kimberly said, when we get to EG, we're going to have to use Pythagorean theorem again. So for EG, I need to be looking at, well, change colors for me here. I need to be looking at this triangle. So Trinity, how would I set up Pythagorean theorem for that triangle? Which one's going to be my hypotenuse? I'm going to call this side right. Actually, let's use a different letter. I'm going to call that side right there Y. So Y squared plus 18 squared. So, you are perfectly welcome on this. You're perfectly welcome to shortcut that some. Like do 22 squared minus 18 squared, because you're going to have to square them both and subtract. So that's going to give you Y squared equals 160. What do you have to do to get rid of the square? We would square root. So we get 12.649. There. So that'll fill out that circle. Not circle, triangle. Okay, some pieces of these questions are super easy because you just have to say, oh, these two things are the same. But some of them are going to require some Pythagorean theorem. All right, any questions there? All right, let's go back to our notes. We're going to skip the examples because I'm doing them from the worksheet instead. Okay, next we're going to look at the incenter. So the in-center is going to be where the angle bisectors intersect. What is an angle bisector going to do? Cuts an angle in half. So in this case, the angle bisectors are these lines right here, and right here, that cut those angles in half. So those are called angle bisectors. Okay, so if we want to list those out, it's going to be B, P, C, P, and A, P. Now, the in-center is always equidistant from the sides of the triangle. So, when we're looking at our in-center here, it is the same distance away from the sides. The shortest distance from a point to a line is the perpendicular distance right here. So, this little piece right here would equal this piece, would equal this piece. So our in-center here would be P. And I am not going to list congruent statements because I've just marked it here. These three little pieces are the same. Yeah, that'll be fine. All right, let's add that to our note card. So it is the second one here. I would label this my in-center. Let's highlight this line, and this line. Those are called our angle bisectors. And let's also mark this little piece equal to this little piece equal to this little piece. All right, got two more. Stick with me here. All right, so medians and centroids. So we need to go over what a median is because the name median doesn't really tell you what it does. Perpendicular bisector tells you what it's doing. Angle bisector tells you what it's doing. The word median doesn't really tell you what is happening with the points. So a median is a segment that joins, get my pen again here, joining a vertex to the midpoint of the opposite side. And the three medians of a triangle intersect at a point called the centroid. and if I remember correctly, the centroid is like your center of mass for that triangle. So like if we could cut this triangle out and balance it like on the point of a pencil, we would need to put our pencil point right there at the centroid there. So it'd be your center of mass. That center of mass is really important for like different design things. Whenever you are like, it could be for all different kinds of things. Okay. Yeah, this particular median is of a triangle and does not really have anything to do with the mean, median, and mode stuff. Yeah. I mean, it does connect the midpoint, and median's a middle number, so it's slightly related in its meaning, but a little bit different. So the medians here, medians go all the way across a triangle, so it would be BF would be a median. I'm going to use different colors for them because where they cross, they're easy to get mixed up. Then I would have AE. And then last, I would have CD. And that centroid would be that point P there in the middle. Now, the medians have kind of a strange property that is going to happen for the medians. Each median, if we look at where they cross right here, gets split into like a short piece and a long piece, right? So, for example, PF right here is our short piece, and BF would be our long piece. Or not BF, PB would be our longer piece. So, whenever that median gets split into a short piece and a long piece, it should always be true that the short piece is half the length of the long piece. Or we could say the long piece is twice as long as the short piece. So like we could say here that special property, we could say something like BP equals 2 times FP. I think this is a little bit easier to see if we use actual numbers. So let's say that PF, let's say right here that has a length of 4. If PF has a length of 4, what is the length of BP going to be? It would be 8. It's just twice as big. What about if I said that AP has a length of 12? Okay, then PE would be 6 right here. Now, obviously, I haven't measured those out. That might be totally inaccurate and impossible for this triangle, but I think it helps just to see how those are related to each other. Okay, let's add this to our I'm using different colors because where they intersect, I think they are a little harder to overlap. These are called our medians. And in general, I find that students just do the best with this if you just use some numbers. So like if we do on that problem where we did like 4 here and 8 here, you can write down like the properties more specifically there, but the short piece is half of the long piece. Oh, we didn't go over and do a problem for in center, did we? We'll do them both now. Okay, everybody have that? Okay. All right. Let's go to number 5. Okay. So for number 5, we're given a centroid. A centroid, again, connects our midpoints to the opposite side. And they tell us that AG, so from A to G here, that is 26. They give us that BC is 44. So from B all the way down to C, that's 44. And DG is 12. Okay, so they're going to ask us for GF first. That is this piece right here. What is the length of GF going to be? Okay. No. GF is, okay, Hannah is correct. It is 13. There. Okay, because this is the short piece of the median, it is going to be half of the long piece of the median. Okay, very good. All right. Then they also ask us for A to F over here, and that we can just add those two pieces together since we now know that this is 13. That is going to be 39. Okay. Next, they ask us for FC. So FC right here is 22. It's just half of that 44. Then they're going to ask us for GB. So GB, yep, it's the bigger half, so we just have to double. We'll get 24. And then we have DB, and DB is just going to be 36. We'll add those two together. I like these. I think they're a little bit easier because you don't have any right angles in these, so they can't ask you something where you have to do Pythagorean theorem for it. Yeah, it's not that bad, but it does take a little bit longer, especially when the other parts are so quick. Now, I do want us to go look at 6. We're not going to do all of 6, but I want us to look at a piece of 6 here. Okay, so 6 is going to be a little different. 6 is going to tell us the LN. There was plenty of time to write that down if you were not.
No, I wrote it in the wrong spot.
Oh, okay.
I paid attention.
Okay, good.
I just wrote it in 6 instead of 5.
Gotcha. All right, so LN is 72. This whole thing is 72. Right there. And then it's going to ask us for like Q here, just this piece. What do you guys think about that? What should we do? No. Because does that point Q, does that cut it in half? Does that cut 72 in half? It's a third, exactly. Because if I know, like, if I've got like this length right here, this piece over here is twice that long. So if I cut this piece in half, I've got 3 equal pieces, right? So if they give me the whole length of the median, I can do 72 divided by 3, which should give me 24 there. So each one of these little pieces right here would be 24. And so that means that for the piece that they're asking me for here, LQ, I would get 48. And then QN would be 24.
Yes, Ray, what is that?
Fire drill.
Oh. Can you hold it down the stairs? Why does a fire drill take place? Is this like Max's drill?
I feel pretty confident that it's a drill. We have to have one every month. It's usually these are the least useful. There's not a lot of properties for them, but that is it's going to be the orthocenter. The orthocenter. We did not finish 6, but I just want to do that first part. The rest of it you should be able to do from that. The altitude is the segment joining a vertex to the opposite side so that it is perpendicular to that side. Now, altitudes are a little bit odd because altitudes are not always on the inside of a triangle. So, I have 3 different triangles here. The first one, if we take that top vertex and we draw the altitude, we would just draw a line straight down perpendicular to the opposite side. That would be your altitude. This is like the most common type of altitude that you will see. But if I try to do an altitude for this next triangle, I cannot connect it to any point on this line right here and make it perpendicular, right? It's got to be too slanty. So what you would have to do here is like extend this line out and drop a line straight down. So the altitude is on the outside of the triangle there. Another word that sometimes is used for altitude is that height of that triangle. So it's like how high it would sit up off the table if we had that edge on the table there. And then the last possibility, if I look at an altitude for the last triangle, this is a right triangle. So if I drop an altitude down here, it is just one of the sides. So altitudes can be inside of a triangle, outside of a triangle, or actually be one of the sides of the triangle if you have a right triangle. Okay, the 3 altitudes of a triangle intersect at a point called the orthocenter. So your altitudes here would be BF, CD, and EA. And the orthocenter here is P. Okay. Let's add this to our note card as well, our little half note card we've got there. So it is this last one. I can go back to it. Has everybody got this? CD. Okay, let's add this to our note card. Oh, that's not the note card. There's the note card. Orthocenter. I would just, I'm going to highlight the altitudes here. Well, I guess I was going to switch colors. Oh, I did. Just not when I thought I was going to. And those are called our altitudes. Okay, so those 4 things are the ones that we have to know. You get to use this on your quiz that we will have Tuesday, and then the test is probably, let's see, I think I have it for Thursday next week. So we just have one more section after this, and it's parallelograms, and it is really fast. It's not nearly as extensive as what we're doing here. So I think we'll be able to do those pretty quickly.